Hey, hi, Jirin. You there? Are you able to hear me?
Yeah, good evening.
Okay, good.
Good morning.
Let's continue our discussion on Cisco Viptela SD-WAN. So by now we have already seen that what are the four components. We have the three controllers, the vManage, vBond, and the vSmart, and then the WAN edges, which were originally called as what? vEdges, because this was an originally Viptela product. So everywhere they used to Viptela used to have V as the prefix, like Cisco is having C as a prefix in their iOS images name. Any router switch iOS image name, if you see, it always starts with small c. So in case of Viptela, we have vManage, vBond, vSmart, vEdges link. Okay. Now, as I told you guys that the control plane is no longer residing on the router. The control plane has been decoupled, it has been separated, and now we have a centralized control plane that will reside where? On the vSmart control. So here is a vSmart. Let's say this will be our vSmart controller, and let's say we have the WAN edges. Just to explain, I'll draw only, let's say, 3 WAN edges in 3 different locations, maybe. And then we have the underlay, some WAN. It could be internet or it could be MPLS. Through this WAN service, all these devices are basically, let's assume that they have reachability to each other. All these devices have authenticated with the vBond, and all the devices we have the vManage separately. Now, once all these components have been installed, doing that. Now the next question comes with what? The routes ultimately. So let's say this is location A. Location A, they have, let's say they have a couple of segments. There could be a possibility behind this WAN edges. There could be, there could be a traditional router. They can have a traditional network also, non-SD-WAN, traditional WAN network also. This router might be connected. This WAN edge might be connected to a traditional router. Normally, we depict traditional router like this circle and X cross inside, whereas WAN edges are depicted as square boxes. So this is our, let's say, this is VB edge, or it could be C edge. Collectively, we call them as what? WAN edges. This is a V edge. Let's say this WAN edge has 2 segments, A, B. This guy has 2 segments, 2 networks, or 2 subnets. So ultimately, the data has to flow through all this A, B, C, D, E, F. But this WAN edge, let us call it a VH1, VH1. I'm just going to write VH2. This is VH3. So VH1 knows AB, VH2 knows CD, and VH3 knows its own directly connected network or whatever it is learning. Let's say it will learn from this router. Maybe this router has a network X. So it will learn about this through how a router will learn about a remote network. How a router learns about a remote network. Like that. A router learns remote network through routing. Either we configure on VH3 a static route pointing for network X, or we configure some routing protocol. So what are the routing protocols supported in Cisco Viptela SD-WAN? Cisco router. Let's assume that this is a Cisco router. This is a Cisco router. So Cisco router, we know that it supports static routing, it supports RAID, the open protocol, it supports OSPF. Cisco router also supports EIGRP. And then we can even have BGP also. So these are the routing protocols which we are, traditionally we are aware of. Now, what about this? Originally, this Viptela, this SD-WAN, this is a product of this company. So naturally, Viptela, we all know that EIGRP is a proprietary protocol, routing protocol of Cisco. So originally, this Viptela SD-WAN solution was not supporting EIGRP originally. But once Cisco took over Viptela, once it came under their portfolio, Viptela SD-WAN became part of Cisco's product range. Then what happened? They modified the images, the iOS, which is running on this WAN edges to support even EIGRP. So RIP is not supported, but OSPF is supported, BGP is supported, EIGRP is supported, and even static routing is also. Static routing everybody does. So static is also supported. So let's assume that this WAN edge, it will learn this network X through static routing, or it could run this with open standard protocol OSPF. So maybe we have, let's assume that we have OSPF later on. So whatever way this WAN H3 learns about network X, ultimately what is the requirement? A, B, C, A, B, users in A, B, users in CD, they would like to access, maybe the resources in E, F, and X. That is a requirement. Now the question is what? Traditionally, these routers, what will configure? We configure these routing protocols. But here now, we are not going to configure any routing protocols because this is not now traditional WAN. This is SD-WAN. In SD-WAN, the WAN edges, they don't have any, and there is no routing running between, there is no traditional routing running between these WAN edges. So how they are going to, and they are not going to extend the routes directly like that. So how the routes of VH1 or WAN edge 1, this segment AB, how WAN edge 2 will learn, and vice versa. Like that, how these three routers, how these three WAN edges will extend their routes. They cannot extend directly, as I told you. So what will happen? They have to send these routes to vSmart, and then vSmart will, propagate it to the other locations. So let's say VH1 want to inform vSmart. Now you have to consider vSmart is also like what? A router at this stage, because it is having what we have this centralized control plane. Here is the control plane now. So how vSmart will learn? How a router with WAN edge 1 will send these routes to this vSmart. For this, what will happen? There will be what? A protocol which is going to run. And that protocol is Viptela's proprietary protocol, like how Cisco has their own proprietary protocol EIGRP. The same way, Viptela, they have created their own protocol, which is known as what? OMP, Overlay Management Protocol. So OMP stands for what? Overlay Management Protocol. So this manages what will happen once we have configured all the components in Cisco Viptela SD-WAN. What will happen? OMP protocol is enabled by default. OMP protocol is enabled by default. We don't need to specify that we have to, OMP has to be enabled. It is enabled by default, and only OMP will run between this centralized control plane and the WAN agents. Here we cannot have static route. Here we cannot have all these traditional routing protocols. Only one protocol. So through OMP, what will happen? There will be what? This will be OMP is also like ultimately a routing protocol, but it is a proprietary protocol. And here we'll have OMP neighborship. So like how we used to have OSPF neighborship, EIGRP neighborship, BGP neighborship. Same way this protocol, since it is enabled, what will happen once we have configured all the components, then manage one will inform the vSmart. But the thing is that, as I said in the previous session, that these segments will be where in the service VPN. So we have actually the service VPNs. For the time being, let's say I'm going to have 2 service VPNs. Service VPNs will be like VRFs, separate, or like VLANs. So VPNs are always denoted by what? A number. So let's assume that segment A is in service VPN 100 and this is in 200. This is service VPN 100. This is like service VPN 100 over here also. This is also, let's say, service VPN 100 configured on this WAN edge. So what will happen when WAN edge? Okay, when this WAN edge 1 will add forward this two routes to vSmart A and B. So it is going to forward this as what? An OMP route. So once they have become OMP neighbors, then WAN edge will send this route as what? OMP route. So this is known as what? OMP route. So we have WAN edge OMP neighborship also, and this will be what? OMP routes also. And VH1 is going to now send this route. So how it will send? It will say, yes, I have this, I have this prefix or this network, I have this prefix A, I have this prefix A, and it will also inform that it is in service VPN 100. And it also has to inform that it has the prefix B and it is in service VPN, let's say, So now once this vSmart receives these two OMP routes, what it will do? It is going to maintain a routing table. Okay, it is going to maintain. We can see this OMP route. We'll see later what is the command, how to see this route. All that thing we'll see little later. But at this moment, let's say now vSmart has received these two routes. When it receives these two routes, vSmart is going to now maintain that okay, network prefix A is in VLAN 100. Prefix B is in VLAN 200. Like that, it will note down first of all. Same way, let's say WAN H2, it will pass on its route. It will also send its route. So WAN H2 also will say C 100 and D in 200. So now vSmart will like that, slowly it will build up this OMP routing table. Same way from here, ultimately this E will come here. They will be all in VLAN 100, and here sorry, F will be there, and let's say network X. So this will be B, D, and F will be in with this 200. So anytime if you see the routing table, the traditional routers routing table, when we do on a Cisco router, show IP route. On a traditional router, the routing table command is what? We do show IP route command. What we see in the show IP route command? We see the route. Let's say we see this A. Network A is there. And then we also see what? Via. Right? We see via. It will show that okay, it is via some IP address. That is called as what? We call it as what? Next hop. So now, once vSmart has collected all these routes, all the managers have passed down their routes, passed down the prefixes to vSmart. Now vSmart knows all the routes. But how vSmart will come to know that A and B belongs to Vantage 1? What will be the next stop? So here also we have via. So over here also we have via. So when VH1 is forwarding this, when VH1 is forwarding this route, its prefixes to vSmart, it is forwarding the prefix plus it is also forwarding the information of which service VPN the route, the prefix belongs to, like that. Because without service VPN, there cannot be a route. You cannot send a route without any service VPN has to be there. It is mandatory. Like VRF. Because why we have two segments? Because maybe we don't want them to communicate between each other. If I want the A and B to communicate with each other, then they will be part of the same service VPN. Like if you see here, F and X, I put them in the same service VPN. So by default, what will happen? Users of X will be able to access resources in F, segment F, or users of segment F will be able to send and receive data to segment X. Like how two interfaces belongs to the same VPN, same VLAN, they are able to communicate. Two interface, they belong to the same VRF, they will communicate with each other by default. There is connectivity by default. So same thing applies for the service VPNs also. Last time I said that every device has what? Unique ID, and that is called as what? System ID. Every device has a unique ID, router ID. It will be some IP address. Let's assume that on VH1, the IP address, this system ID is like, let's say 1.1.1.1. just assuming, or let's say 10.1.1.1. This is, let's assume that this is 10.1.2.2, like that. And like that, let's say this guy has, 10 dot, sorry, 1.3.3, like that, something. It could be anything. So every device, every WAN edge has a mandatory what? System ID. So what will happen when WAN edge 1 is advertising its prefix vSmart? It is sending the prefix, it is sending the service VPN information, and now it will also send what? The next stop. It will send what? Via 10 dot.
Say that again.
When WAN edge 1 is advertising its prefix A and B, when WAN edge is advertising its prefix A and B along with the routes information, along with the service VPN information, they also have to send the next stop. So here A will be via, it will not send the, it will not send its, this WAN interface. This WAN interface is what? Underlay. This reachability between them is what? Underlay. As I said, this protocol OMP is going to run over the underlay. It is like in traditional WAN, we have, we have IGP running. With IGP, we have reachability. Once we have IGP reachability, then what we do? We configure what? BGP. And in BGP, we advertise what? The prefixes. So it goes as what? BGP. So to understand OMP, one needs to know, one needs to have understanding of BGP. So OMP is similar to BGP. OMP is similar to BGP. It can carry various attributes. So you see prefixes there. This is prefix. All the prefixes. Information. Service VPN information. And then via means next stop. But this next stop is not the physical IP address. The next stop is not the physical IP address. Like that. They'll send what? This one. Okay. Like that. 10.1.1. So B also will be 10.1.1.1. Like that. And C will be 10.1.2.2. Like this. Same way E will be 10.1.3. Like this. In same way for this one also. D will be 10.1.2.2. And this 2 will be 10.1.3.2. This via, this next stop in now Viptela SD-WAN, this is called as what? This via whatever this next stop, this is called, let me remove. This is called as what? T-lock. This is known as what? T-lock. T-lock stands for transport locator. T-lock stands for what? Transport locator. This is called as what? T-lock. T-lock is nothing but raw. In traditional WAN, we call it as what? In traditional routing, we call it as what? Next stop, via T-lock. But this T-lock, now, this, as I said, no, say, let's assume that this is a private IP. Let's assume that this is a private IP, 10.1.1.1, 10.1.2.2. We have configured. Now this is, let's say, WAN service is what? This WAN service is what? Internet. On internet, private IP, we all know that it is not allowed like that. So what will happen? The vSmarts, these managers, when they're advertising, they're also informing that, okay, this is our, this is our T-lock, and this T-lock is reachable via their real, their real WAN IP, real IP, whatever is this real. Let's assume that this real IP on the internet, let's say this is a public IP, let's say 100.1.1.1. This guy's IP is, let's say, 200. Let's assume that this is 11 dot, like this, something public IP. So here for 2, it will be 200.1.1.1, and same way for 10.3.3 will be like 211, 1.1.1, like this. So like that. So now vSmart has complete information about all the prefixes belonging to all the WAN agents. Once vSmart has received this information from WAN 1, what it will do? Now vSmart job is to what? Forward this information. Same way this is it has informed. I'm just writing here F and X. Now once vSmart learns about all the prefixes through OMP, now what it will do? Forward. See, let me use a different color. vSmart now will forward. We'll remove this now. Now vSmart will now forward the routes. What it will forward now? It will forward now the routes. It will check, okay, VH1 has 2 service VPNs, because see, when VH1 advertise its in prefix A and B, it also advertise what? Service VPNs. So now vSmart will say, okay, hey VanH1, thank you for giving me your routes. Now I will give you in routes of the other WAN agents. So it will send now what? T, and let's say E, they are in service VPN 100, like that, and then D, F, X in service VPN 200, and it will also inform that, okay, this C is available via T-lock 10.1. Like that. Correct. And E, it will inform that E is basically 10.1.3.3, and this is reachable. 10.1.2.2 is reachable via its real IP 100.1.1.1. Sorry, 100.1. C is 200, right? So this will be 200. Whereas this one is 211, the real public IP. So now you see Vantage 1 learns about the routes of the remaining locations. And same way, vSmart will repeat for this guy also. vSmart will repeat for this one also. Suppose now, let's assume that we have one more location. We have a new location. Let's say this is VH4, location 4. Okay, this is VH4. It also has maybe two segments. Segment A, prefix A and prefix M and N. So same way, this one also will advertise. But now let's assume that on this VH4, this MN on this has to be in some service VPN. So let's say this service VPN. Over here, let's say a configured service VPN. Let's say both M and N. Let's say they are in service VPN 300. So now what will happen? vSmart will learn about MNN, or MNN also will now, it is going to learn M and N via whatever, let's say 10.1.4.4. It will be 300 and TLOG will be 10.1.4.4. whatever the WAN, the real IP also, all the like how the VH1, VH2, VH3 informs vSmart. Same way VH4 also will repeat the same thing. Nothing different through OMP. This will be all forwarded through OMP. What vSmart will do now? If you see VH4 now has own service VPN different compared to VH1, VH2, VH3. So now will vSmart forward this information of A, B, C, D, E, F? No. vSmart intelligently knows that VH4 has told me it has only service VPN 300. It has not sent me any information about its service. Is it having service VPN 100 or is it having service VPN 200? No, I don't have that information. So what will happen? vSmart now will not send any route, it will not advertise any routes back to VH4. And same way, vSmart, when it learns about MNM in VPN service VPN 300, vSmart knows that VH1, VH2, VH3, these guys, they have service VPN 100 and 200. They don't have 300. So it will not forward them this MNN information. So intelligently, you'll see only the VH1, only the Vantages who has a particular service VPN. Then vSmart will only forward routes of belonging to that service VPN only. vSmart will not advertise routes of other service VPN if it is not existing on the Vantage. There is no OMP running between the Vantages. OMP neighborship is only with vSmart. Every Vantage will inform about its prefixes along with service VPN information, along with TLOG, along with its real IP address, whatever. All this information they are supposed to pass on only to vSmart. And then vSmart responsibility is to forward that information correctly to those other Vantages who need it. VLAN 1, service VPN information 100 and 200 will be passed on between VH1, VH2, VH3. But service VPN 300 information will not be passed to VH1, VH2, VH3, and vice versa for VH4. VH4, vSmart will never forward routes belonging to service VPN 100 and 200. So that means from this, what we can understand, there is no communication between two different service VPNs. Each service VPN is like a separate VRF by default. So there will be no exchange of routes between two service VPNs. Never, by default. Later on, we'll see if we want to, advertise routes from one service. We want to have reachability between one service VPN with another service VPN. Then we'll see how to do that. That will be one of the lab later on. But initially, you have to remember that routes of one service VPN will not be forwarded to another service VPN, and hence there won't be any connectivity between two service VPNs. Users of one service VPN will never be able to access resources in another service VPN by default. So far, so good. Any doubts? Any questions?
Good to go.
Okay.
No, so far so good. Yeah.
All right. Thanks. So this is OMP. OMP neighborship is there only with vSmart. Managers don't have. And once they learn about each other routes, then ultimately how the data will flow. Suppose a user in segment A wants to communicate with a resource, it is trying to access a server in segment E. How it will how a user A will be accessing, sending the data. How the data will go? There, first of all, there will be what? An IPsec tunnel. There will be an IPsec tunnel. So VH1 will establish what? An IPsec tunnel from here to here, like this. And then user of A, when it will come from here, data, it will come normally up to here. But when VH1 is now checking, it will say that yes, E is available via 10.1.2.2. And 10.1.2.2 is available via the IP address. The real IP address is what? 200. So what it will, it is available, E is available via 10.1.3.3. Prefix, this network E belongs to VH3. So it knows that VH3 is 10.1.3.3 and its real IP is root. So what will happen? There will be a VPN session from here, a tunnel. Like this. This is the data. So in this inside, the data is going to go from, let's say, from A to segment E, like that. And this is what? An IPsec tunnel. And this IPsec tunnel, it will be what? Encrypted. It will be encrypted only. The source IP will be what? 100.1.1.1 and destination IP will be what? 200.1.1.1. See, originally the prefix will be like this. Let me generate a packet for you guys. When a user in A is trying to access a user in E, let's say, user in A is basically doing telnet. It is doing telnet to some server in E, let's say, or it is doing a ping. It's simple. Let's say A is pinging E. So ping basically means what? ICMP. So application will be what? ICMP. This ICMP, what it will generate? It will generate what? A packet. Okay. It will be what? Echo. It will generate an echo request. Echo request. What is the type code, guys? Type code. What is the type code for echo request?
One.
It is type code 8. Like that. So ICMP will generate a echo request packet. And then this is the payload. And then to this payload will be attached what? The IP header. When I say IP means what? IPv4. And IPv4 has so many fields. As far as now a packet is concerned, I will just show only 3 fields. Source IP, source address, and destination address, and the protocol. So what is protocol? Protocol will be clearly seen as what? ICMP. And what is the protocol number for ICMP? 1. Source address will be what? A. Just writing A. Or let's say A dot, no, A1 something. And let's say it is accessing a server whose IP is something E5 something. And it will be an IP address. I'm not defining A and B like that. So this becomes the packet. This is the original packet. This original packet now cannot go outside as clear text. What will happen? IPsec. In IPsec, what will happen? Which is the protocol whose responsibility is to encrypt this data? ESP. So what will happen over here? ESP, what it will do? It will attach a new header. This is an IP which the world knows, everybody on the internet knows. And now this is called as, we call this as what? ESP header. This is known as what? The ESP header. And what ESP is going to do? The original packet is going to get now what? Encrypted. So like this encrypted packet will go with an ESP header, which will be in clear text because this is the transport ultimately. On the internet, this IP must be visible. Then only the packet will get forwarded across the internet or across the WAN cloud, whatever is the WAN. So on the internet, if somebody intercepts this packet, they will find it what? And it is an encrypted packet. They will not be able to decrypt this packet because it is ESP. So this whole thing is now become what? An ESP packet. The whole thing we call it as what? ESP packet. So if we capture this packet in Wireshark, we'll see that it will only show as what? ESP. When we try to read this content, we will not be able to read the content normal because it might be encrypted by some strong algorithm. ESP has various algorithms like AES is there. There are so many algorithms available. Plus, there could be possibility hashing might be also there. It could be HMAC 384-bit hashing, very powerful algorithm. So ESP will use encryption as well as hashing algorithm to make it more difficult for people to decrypt the packet. So this is how the data will flow from A to E. It will not flow from A will like VH1 will not forward the packet first to vSmart. vSmart job is to only extend the routes. Once the vantages now these vantages when they receive the route, they are also maintaining the routing table. They also maintain, but they are not calculating the routing table. They did not calculate how do I reach E. They got ready-made information vSmart. That's the reason this is called as what centralized control plane. Every vantage still is having like a control because every vantage is still maintaining what a routing table. If I do show IP route this on vantage one, we'll see that it will say yes, I know A and B. A and B is my directly connected. C, D, E, F. It will know that okay, these are the routes which I'm learning, and I know where is C, where is E. How do I reach them? How to send traffic to these destinations? So all that information every vantage is maintaining, but they are not meant. Vantage one did not communicated the route information with the other vantage directly. They first forwarded the route information to vSmart, then vSmart is forwarding back the information to them. But when actual traffic will come, actual traffic will not flow from one VH1 to vSmart and then from vSmart to then because then it becomes what suboptimal. vSmart is not basically a router kind of. vSmart does not come in the path of the data plane. So this is data plane. This traffic is what? Data plane traffic. In the data plane, vSmart is not going to come in the path. This is data plane traffic, end user traffic, forwarding plane. Every router is maintaining what? A forwarding plane. In the forwarding plane, the next stop will be what? These real IPs. Like that. So they know how to send the data on the internet. So everybody on the internet is aware about this public IP. If it is in WAN services internet, then all these IP addresses of this WAN edges will be what? Private IP. Yeah, public IP. Is it okay, guys? So
Yeah.
vSmart doesn't come in the path of data plane. vSmart is only managing the control plane, meaning the route information, exchanging of routes. WAN edges are not exchanging routes with each other directly. They are exchanging the routes through vSmart. This is called as what? Centralized control plane. Centralized. And all this routes exchange will happen through what? This protocol, OMP. And OMP is a scalable protocol like BGP. It can handle very large number of routes because this we would tell a SD-WAN, this solution has been created for very large deployments. So like BGP, it will have this thing. And what about the like BGP is what type of protocol? It is what BGP is TCP protocol or an UDP protocol? BGP is TCP protocol or UDP protocol?
TCP.
It is TCP. So if it is TCP, what was the port for BGP?
179.
Yes. So BGP port number is what? TCP 179. What about this OMP protocol?
It's
Whenever
UDP, right?
whenever we say any protocol, whenever we talk about any protocol, this protocol will have only two things. There are only two possibilities. Either this whatever protocol we are talking about, the protocol will have either what a protocol number or it will have what a port number. So this TCP 179. We call it as what port. We say what? TCP port 179 BGP. What about OSPF, guys? OSPF has what? OSPF is TCP or UDP?
TCP.
No, Dylan. OSPF, EIGRP, they are protocols. They don't have port numbers. Like how ICMP, see, I have written here ICMP, protocol number 1. Same way,
Quick
OSPF,
question.
it has what? Protocol number 89. Protocol number 89. So any protocol, whether it is routing protocol, whether it is any protocol, only two possible. Either it might have a protocol number or it might have a port number. And port number could be UDP or TCP. So if you see now, BGP is a reliable. TCP means what? BGP is a reliable routing protocol because it has to carry very large number of routes. How about OMP? OMP also Viptela created to carry what? Exchange what? Very large number of routes. So when there could be very large number of routes, the communication, the exchange must happen what? Reliably. So that's the reason this OMP is also what? A TCP based protocol. OMP is also TCP based protocol. And if it is TCP based protocol, then it must have what? A port number. So TCP means it must have a port number. So any idea what is the OMP protocol TCP port number? It is very easy. See, this Viptela, when they created this OMP, they kept in mind what about BGP? As I said, to understand OMP, BGP understanding has to be there. So they kept in mind BGP. BGP is having what? Port number 179. So what they did, these guys, OMP also has a TCP port number. No, now two protocols cannot have the same protocol number. So 179 is part of TCP, but before 179, there is something else, and that will be homework for you guys. And today homework has become child's play. Today homework has become like child's play. What? Why? Why I'm saying homework is like child's play?
Why?
GPT.
Because we have
Oh.
what? The AI nowadays, AI models. We have Chat GPT, we have Grok. You can use any of this. No, nobody today does Google. Nobody does Google. You just take your phone, open Chat GPT. By the way, do you guys have Chat GPT or Grok in your mobiles?
Yes.
Okay, good. Just ask Grok. Hey Grok, what's the port number for Viptela OMP protocol? And it will not only give you the protocol number, it will give other lot of information. That's the difference between Google search and nowadays what we use Chat GPT or Grok. Google search will only give you links and maybe 2-3 line description, maybe whatever we search in Google. But the AI models, it will show you pages after pages if you want information. Loads of information will be provided. So that will be homework. But thing is that half the part I've done. See, it is 179. It will be having 179 because OMP has similarities to BGP. Why Viptela included 179? Because OMP is similar to BGP. It is reliable. It is TCP. So here also OMP is also reliable. Neighborship is there in BGP. OMP also has neighborship. In BGP we have various attributes. Here also OMP, in OMP also we can have various attributes. Similar protocol, OMP, but proprietary protocol of Viptela. And now today OMP has become proprietary protocol of Cisco ultimately because Cisco has taken over Viptela. So you have to find, it is 5-digit number. I'm not going to give you this. You just try to find out for yourself. Okay. Next session, if you are not able to find, if ChatGPT or Grok is not able to help you, then next session I will give you the TCP. So it is also new. It is also a reliable protocol. So very important thing, OMP is like at the heart of Cisco VIP Tele SD-WAN because ultimately the routes exchange will happen through this protocol. Right. We cannot have anything else. Between vSmart and the WAN agents, only OMP will run. OMP runs only between vSmart and vSmart controller and the WAN agents, not between vManage or vSmart, vBond. vBond job is only for authentication. vManage is for management of the complete single window solution. So this is how ultimately will happen. Now we have the core components. I'm just writing VM for vManage, VB for vBond, vSmart like this, and then the WAN edges. This is the data plane. This is our CP control plane, and there will be some WAN to which all these components are connected to each other. That is the underlay. This is underlay. Now, underlay originally is what? Insecure, because initially the communication will happen clear text, but now through vManage, what will happen? We want the communication to happen secure. So first of all, what will happen? Everybody is going to authenticate with vBond. Everybody is going to authenticate. So vBond is meant. So first thing what will happen will be what? Authentication. This authentication plane or will come first in the picture. Now how all these components will authenticate with each other. This is happening, this is going to happen across the internet. Internet means what? Public cloud. So thing is what? This authentication, we want it to be what? Scalable. So it is not meant for only 3 locations. As I said, this solution will scale to what? Maybe tomorrow 3,000 locations. Or it could be maybe 30,000 locations. Or it could be maybe 100,000 locations. Who knows? Like, you take example of Citibank. Citibank, they have branches in all the countries. They have office HSBC. They have all, they have their branches everywhere. Anywhere you go in the world, you'll find a Citibank outlet. Where you can go and maybe withdraw if you want to have cash something. Or you go to any ATM today, it is not necessary that you have an account in Citibank, then you have to go to only Citibank ATM. Today it is what? Any to any. So Citibank, if you see, in US they might have so many, in so many cities they might have offices, branches. Similarly, Citibank, they have basically branches in many cities in India. At least in India, they have their presence in at least 100 cities. Minimum, I'm talking about 100 cities. I don't know Could be more also like that. In India, all the major cities, Citibank branches are there. So we are talking about a solution which can scale maybe 50,000 locations. So whenever you have a scalability thing, so in scalability for authentication, we want a scalable solution. And as I said, for scalable authentication, what is the model? The model we call it as what? PKI, public key infrastructure. Public key infrastructure is also called as what? IKE, Internet Key Exchange. And ultimately, this is based on what? Digital certificates. So every component in Cisco Viptela SD-WAN, they must have what? A digital certificate of their own. And when we said a certificate, it must be properly, the certificate must be what? Properly authorized. You can't have a certificate without anybody's signature, anybody authorizing it, anybody counter signing it. You take an example, you pass a Cisco exam, you get a certificate from Cisco. So whatever certificate you get from Cisco, like maybe a CCNA certificate or CCNP certificate or a CCS certificate, there will be some signing authority. There will be somebody's signature on that certificate. The same way, digital certificates will carry what? A digital signature. And whose digital signature the certificates carry? Who generates this or who authorizes this digital certificate? Every device can generate their certificate, but it has to be signed by somebody else. Some signing authority has to be there, and that signing authority we call it as what? CA, certificate authority. And in the world now, there are so many third-party organizations which provide these CA services. Like Microsoft provides the CA services, Cisco provides CA services, VeriSign provides CA services, Entrust provides CA services. There are various organizations, third-party organizations which provide these CA services, scalable CA services. Viptela, before it was taken over by Cisco, what they did, Viptela, they did not have their own CA service like that. What they did a tie-up by default with one organization which is called as what? Symantec. So original, this is the default. So Viptela had a tie-up with this company, with this organization, Symantec. Plotting the day Symantec will pay you. Okay, we want all our products to get digital certificates. So on the internet, there will be somewhere, there has to be what? A CA. There has to be a CA like that. So all the components initially, before they communicate with each other, all the components, Cisco, Viptela, SD-WAN, before they communicate with, they're supposed to first have what? A digital certificate, properly signed and authorized by a CA server of some organization. So originally, Symantec is there. Now in our lab environment, we are not going to have an actual Symantec like that. So what we'll do, we'll have our own CA server. So I will show you that how to create a CA server. We are going to use a freeware known as what? XCA. So this is a freeware certificate authority software available on the internet. So I will share this software with you so you can set up your own CA server. So I will show you how to set up our own CA server. So we'll set up this CA server will itself have what? Its own certificate. Even this guy also will have its own certificate. I'm just writing DC, digital certificate. Any other device wants to have its own digital certificate. First thing is what? It must have the digital certificate of the CA server. Any device, let's say we manage this server needs to have its own digital certificate. Before that, it must have the CA server digital certificate with it. With using this CA server digital certificate, what it will do? It is going to generate its own digital certificate. It is going to generate its own digital certificate. This digital certificate of CA server actually has what? It has got its fingerprint. Using the fingerprint of the CS server, what will happen? It will create this vManage will create its own CS server digital certificate. It will create its own certificate. Okay, but it will be unsigned. And now, how it will be sent across the internet? We cannot send this information across the internet clear text. That is where this digital certificate of the CS server comes in. Using this digital certificate, as I said, this digital certificate of the CA server has its own fingerprint. Using that fingerprint, this certificate will be sent to this guy, to the CA server. This will be an unsigned certificate. So like this will become what? Like a client. See. So clients, what they do? They generate their own certificate. In that own certificate, they'll write down what is the name, what is the IP address, whatever, what lot of information it can contain. It's a standard, it's a standardized certificate. It's not like a random like any vendor. No, this is called as what? X509 certificate. X.509 certificate. So this is the format. So this X.509 certificate has some fields. That information will be their validity. Any certificate has a validity. So it will have a validity when from what date to what date this certificate is valid for 1 year, 2 year, 3 year, whatever, like that. And then using this from the digital certificate of the CS server, the client, what it does, it uses that fingerprint. It means it has like what? A public key. It has a public key. So using the public key of the CS server, what it will do? It will encrypt this certificate, unsigned certificate is sent to the CS server for signing. Then CS server will check all the contents of the certificate as like that. And then this certificate, the CS server, what it will do? It will sign. Now it will sign the certificate, digital certificate. It will sign the certificate back and send this signed certificate. Now this will be what? A signed certificate. So like this, all the components we manage, we bond, we smart, all the managers, they must have what? The signed, authorized, valid digital certificates. Is that? So then any two components, when they communicate with each other, any two
Hey,
components.
Abid,
Yes, yes.
is it okay if is it a good stopping point now?
Oh, we can stop. Yeah, I didn't. Sorry.
No, okay. I was thinking maybe you get to a stopping point. I don't want to cut you off. So
Okay. So I just end up with this, that once they have the certificate, using this digital certificates, they authenticate with each other.
Okay,
Okay, like that.
all right.
Once authentication successful, then they become part of a family. That's it. All right, then we'll end for the day over here. Okay.
All right.
So
Hey,
now,
hey,
so see
Tom,
you guys.
Hey, what's up?
Tom,
Yes,
are you good with Monday? I know Monday's holiday, isn't it?
I never holiday for me.
Oh,
Yes, I'm
that's
good.
right. Okay, I didn't know if you had something planned with your family, so.
Hey guys, sorry,
Uh,
yes, sorry for yesterday. I don't know. The
Oh,
alarm
okay,
went.
that happens to all of us, don't worry. You're waking up 4:30 in the morning, it's crazy. Okay, hey, Tom, I'll meet you, Wellington's gonna see us there too.
All
Okay,
right,
see you
I'll
guys.
be there
I
like
mean-
in 15 minutes.
Okay, I'll
All
be there
right,
about
buddy.
7, 8. All right, thanks, Abid.
Thanks,
All right,
guys.
bye. Thank
Okay,
you very much, Abib. Thank you. Bye.
you're welcome. See you on
Have
Monday.
a good day.
Have a nice weekend.
You too.
You too, take care.
Thank you.